So today we're going to be reviewing and talking about all things angles and how we learned in Math 3 that we talk about angles on the coordinate plane. So things to remember as we get into upper level mathematics, we often use radians more than we do degrees. If you recall from Math 3, radians always has pi in it. So 3 pi over 4, 5 pi over 2. It's always got pi in it. That's how we know we're dealing with radians. Degrees always has to have the degree symbol. And we can convert back and forth between radians and degrees because they're proportional. So if you take however many radians you have over pi, it's going to be the same proportion as the number of degrees you have over 180, because halfway around a circle is 180 degrees or pi radians. And you can just cross multiply, solve the proportion for whichever one you're actually trying to convert to. So convert radians to degrees and degrees to radians. So if I'm trying to go from degrees, I remember that there are 180 degrees in the half circle. So 127 would be to 180 degrees, the same way that number of radians would be to pi radians. So really, to figure out how many radians it is, all I end up having to do is multiply both sides by pi. So the big trick is reducing this fraction. So I definitely think 3 will divide it, although I'm not sure. But I end up with 127 over 180 pi. And then we can try to reduce it if we think that it will reduce. And then if we're going the other way, if we're going from radians to degrees, I would be like, okay, so 2 pi over 5 radians is going to go to pi for the half circle. And then however many degrees I have is going to go to 180. So again, to figure out what it is that I'm looking for, I'm just going to have to multiply both sides by 180. The pi on the top and the pi on the bottom actually cancel one another out, and all I end up with is 2/5 times 180. 180 divided by 5 is going to be 36, and 36 times 2 is going to be 72 degrees. So going back and forth between radians and degrees. All right, so quadrants, things to remember from Math 3. We talked about that on the coordinate plane, we measure angles starting from the positive x-axis. We say that the center is at the origin, and this is going to be the initial side of the angle. So there's some vocabulary to go back and remember. And we rotate around the origin in a counterclockwise direction, right? So we go counterclockwise around, and wherever the angle ends, that's the terminal side of the angle. That's where it ends. So you have your initial side of the angle and your terminal side of the angle, and we are going in a counterclockwise direction. And we end up in different quadrants. And it's always important to know which quadrant you end up in, because when we're doing trig, we know that the quadrants have to do with what sign our trig is going to turn out to be. So just as a review, remember our quadrants are quadrant 1, quadrant 2, quadrant 3, and quadrant 4, because that's the start, and that would be the order that the angles would rotate through the quadrants. So 1, 2, 3, and 4 are our quadrants. We talked about, and one of the ways that we can have trig functions is because we're not just dealing with a triangle anymore when we talk about trig. a triangle was limited to 180 degrees or pi radians, but for functions, we want that to be able to continue on. And so when we started looking at angles as a rotation around the coordinate plane, that allowed us to keep going past a full circle. And that's where we ended up having coterminal angles. And they're angles that terminate on they have the same terminal side of their angle, but they're not necessarily the same angle measure. For example, this angle goes about 50 degrees from the initial side to the terminal side. And so that could be one interpretation of that angle. But if I went all the way around and then stopped at that terminal side, so that would be 360 degrees plus 50, which would be 410 degrees. We could also go in the other direction. If you recall, if we go not counterclockwise but clockwise, that means that we're dealing with negative angles. That's how we took care of negative numbers for the sine and cosine for those trig functions. Was negative angles meant you were rotating clockwise. Positive angles meant that you were rotating counterclockwise. So in this case, the angle that would come from this initial side to this terminal side would be 310 degrees. And all three of, negative 310, I'm sorry. All three of these angles are the exact same terminal side on the coordinate plane. So coterminal angles have the same terminal side. But there's an infinite number of angles that could end on this terminal side. And in fact, they're all just 360 degrees apart from each other. If you're trying to find a coterminal side or a coterminal angle to go with any angle, you can just add 360 degrees to it, subtract 360 degrees from it, or add 2 pi to it, or subtract 2 pi from it if it's in radians. Because that would be a full rotation around the circle and you would land in the exact same spot. So again, as an example, if I want to find 3 coterminal angles for each angle, I can just add 360 3 times. I could add 360, subtract 360, and then maybe subtract 360 again. You just have to keep adding and subtracting 360 until you get 3 coterminal angles for each angle. So if I subtract 360 from this one, that's going to be 96, negative 96, I believe. So negative 96 would be coterminal with 264. We could add 360 to it. So 200 and 300 is 500, 60 and 64 is 124. So that's going to be 624 degrees. And that would give us a second. And then if we're looking for a third, we would just have to keep going another 360. And 4, 8, so 984 degrees would also be coterminal with that angle. If it's in radians, remember, we know it's in radians if it's got pi. If I want to find a coterminal angle for this one, I can just add 2 pi to it. But it is a fraction, so I've got to remember how to add fractions. So 2 pi, if I find a common denominator, is going to be 14 pi over 7. So 14 pi over 7 plus negative 3 pi over 7 is going to give me 11 pi over 7. So that would be one coterminal angle. Then I could add 14 pi over 7 again, and that's going to give me 25 pi over 7. So that's a second coterminal angle. And then I could just add 14 pi over 7 again. And that's going to give me 39 pi over 7 to give me my third coterminal angle for that one. Now, reference angles are a very big deal. If you recall, when we did start talking about rotating those angles all around the coordinate plane, in order to find what the meaning of sine and cosine were when we were dealing with an angle that was over 180 degrees, because that sine ratio comes from a right triangle. There's not going to be angles bigger than 90 degrees in that right angle that could have a ratio. And so this is where we talked about having that reflection piece. If I have this angle over here that has a side length and a side length, if I reflect it over here, that side length and that side length are the same amounts. And so when you do that ratio, they're going to give us the same ratio. They just have a different sign. And so even though we're talking about this angle for that terminal side over here, this is its reference angle, the one from an actual right triangle that we're using to get the sine or the cosine for that angle. And so every angle has some reference angle from this first quadrant, those first 90 degrees or those first pi over 2 radians, that it's pulling its sine or cosine from. So to find a reference angle, what you want to realize is that you're always looking for the angle that that terminal side makes with the x-axis. So if you have a terminal side in the first quadrant, you want the angle with the x-axis. If you have a terminal side in the second quadrant, you want its angle with the x-axis. If it's something in the third quadrant, again, you want to find its angle with the x-axis. And if it's in the fourth quadrant, you're looking for its angle with the x-axis. The reference angle is always the angle that terminal side makes with the x-axis. So if something's in quadrant 1, that is the reference angle. So it just stays the same. If something is in quadrant 2, think about an angle that would have a terminal side in quadrant 2. This is going to be the reference angle. So to figure out what the reference angle is, we have to take 180 and subtract whatever the angle was from it to find the reference angle. If it was in radians, it would be pi instead of 180. Now, thinking about if you have a terminal angle in the third, a terminal side in the third quadrant, well, that's going to be the reference angle is going to be what's left over after you take 180 away from it. It's that little piece that's hanging over the side here. So this time I would take the angle and subtract 180 from it to get its reference angle. And then if it's something that happens to end up in the fourth quadrant, well, the reference angle goes up to the x-axis. That's that little bit that it missed going all the way around. So if we take that angle and subtract it from 360, that will always give us the reference angle. So we can find reference angles for all of these if we can figure out what quadrant it's in. That helps us to know what we need to do to find its reference angle. Now, one thing I do want to point out is if something is bigger than 360 or bigger than 2 pi, the first thing you always want to do is find its coterminal angle because the coterminal angle is going to be smaller to deal with. So I always just subtract 360 from it to get it at least between 0 and 360. Same thing goes for negative, because they're going in the wrong direction. I want to figure out at least what its coterminal positive version is before I start trying to figure out quadrants and stuff like that. So if I think about 7 pi over 6, that's just a little bit more than pi. So that's going to put it in the third quadrant. So it's somewhere over here. And I know that if something is over here, I just need to subtract pi from it to figure out what its reference angle is. So I'm going to subtract pi, but I've got to find a common denominator. So I'm just going to put 6 over 6 there. And 7 pi over 6 minus 6 pi over 6 is just going to be 1 pi over 6. So that's going to be the reference angle for this one. For this one, the first thing I notice is it's negative. So if I add 360 to it, that's going to be negative 48. And then if I add 360 to that again, or actually, I can just think about negative 48 for a second. Negative 48 just means it goes backwards 48 degrees. Well, that's going to be its distance from the x-axis, so that means that its reference angle is just going to be positive 48 degrees. That would be the reference angle there. 2 pi over 5. So 2 pi over 5, if we took pi and separated it into 5 equal pieces, 1, 2, 3, 4, 5. 2 pi over 5 ends up in this first quadrant. So if 2 pi over 5 is in the first quadrant, it is the reference angle. 513 is bigger than 360. So I'm going to subtract 360 from it just to kind of figure out what is its coterminal angle. So that's going to be 153 degrees. 153 degrees is going to fall over here in the second quadrant somewhere. And our rule for the second quadrant is just to take 180 and subtract 153 from it to figure out what that little bit left over is going to be. And that's going to give us 27 degrees. So its reference angle is going to be 27 degrees. All right, so the Pythagorean identity, again, if we're thinking about angles on the coordinate plane, they fall into one of the quadrants, 1, 2, 3, or 4. And when we're drawing their reference triangle, we always put that down with the x-axis, so that it has a 90-degree angle with the x-axis. And one of the things that we talked about in Math 3 is that, especially for the unit circle, when we think about the hypotenuse just being 1 unit, the x value of this point and the y value of this point that the terminal side falls on become the side lengths of that right triangle. And because of that, we also started, on the unit circle, we started to realize, oh, well then whatever this angle is, the sine would be opposite over hypotenuse, y over 1, which would just be y, and x over 1 for the cosine, so that's just x. And that's why we were able to say that points on the coordinate plane, the cosine of the angle is the x-coordinate, and the sine of that angle is the y-coordinate. And so we also get one of our identities, the Pythagorean identity, out of this. If x is the same thing as cosine theta, and y is the same thing as sine theta, this is still a right triangle, and that means that the Pythagorean theorem still works. So that means that sine squared theta plus cosine squared theta has to be equal to 1, because a squared plus b squared equals c squared, and 1 squared is just 1. And this is a big deal, because if we know what sine is equal to, then we can find cosine, because sine squared plus cosine squared has to equal 1. So even if I don't have the angle measure, but I know what its sine ratio is equal to, then I can find the cosine ratio, I can find the tangent ratio. I have everything I need to find all of the other trig ratios.